Okay, so welcome back to the channel after a long break. So today we are going to be solving the Advent of Code day 1. For those of you who don't know what Advent of Code is, for a brief introduction, it is an Advent calendar for coders. So there are going to be 25 small programming problems over the course of December. We're a bit late to this. Today is 8th of December, and we are already 8 days into the competition, but we'll be starting from day 1 because I was late to this. So, for the first day, we have our problem. The chief historian is always present for the Brick Christmas sleigh launch, but nobody has seen him in months. Last anyone heard, he was visiting locations that are historically significant to the North Pole. A group of senior historians has asked you to accompany them as they check the places that they think he was the most likely to visit. As each location is checked, they will mark it off their list with a star. They figured the chief historian must be in one of the first 50 places they look, so in order to save Christmas, you need to help them get 50 stars on their list before Santa takes off on December 25th. Collect stars by solving puzzles. The average advent of code thinks you'll gain a star for every solved puzzle, and every puzzle is going to have two parts. So one will be the easier part, and the second one will be the harder part. At the same time, puzzles are supposed to get harder as you advance through the days. So the first day is supposed to be easy. So let's go to our problem. Okay, apparently it starts from here. You haven't even left yet, and the group of elvish senior historians has already hit a problem. Their list of locations to check is currently empty. Eventually, someone decides that the best place to check first would be the chief historian's office. Upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. Instead, the elves discovered an assortment of notes and a list of historically significant locations. They seem to be planning the chief historian was doing before he left. Perhaps these notes can be used to determine which locations to search. Throughout the chief's office, the historically significant locations are listed not by a name but by a unique number called the location ID. To make sure they don't miss anything, the historians split into two groups, each searching the office and trying to create their own complete list of location IDs. There's just one problem. By holding the two lists up side by side, your puzzle input, it quickly becomes clear that the lists aren't very familiar. Maybe you can help the historians reconcile their lists? For example, we have two lists side by side. The lists are only of a small amount. To find out, pair up the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list, and then the second smallest number left number with the second smallest right number, and so on. Okay, so basically we have to find the distance between the two lists. So I think the best way to go about would be just sort the two lists and then like do an element by element subtraction. So within each pair, figure out how far apart the two numbers are, and you'll need to add up all of those distances. For example, if you pair up a 3 from the left with a 7 from the right list, the distance is 4. If you pair up a 9 with a 3, the distance is 6. In the example list above, the pairs and distances would be as follows. The smallest number in the list is 1, and the smallest number in the right is 3. The distance between them is 2. Okay, I think I got it. So, this is our first list, and this is our second list by a different, like, set of historians. What we need to do is we need to just sort them and then just figure out the distance between the two lists. So, for this example, it should be 11. The answer should be 11. Here's our puzzle input. I'm just going to copy it all together. And we are going to, okay. Not supposed to happen. So we are just going to input it right here. So under day 1, we have our input and we are going to dump it out here. So yeah, we have our puzzle input right here. We are going to sort these two lists. I think there are 3 gaps. So there's 1, 2, 3. Yeah, there's 3 spaces between the lists. We'll just create two lists and then just find the difference between them. I I cannot brainstorm of a better way to do this other than brute force. So we have this, we are going to write it. And just to make sure that we aren't on the wrong path, I'll just grab this completely and just new file under day one called test. Hmm, yeah, three spaces. So the same code should work. So there wasn't anything much to explain. We'll just go to the coding part. So we'll create our solution. So first of all, we are going to open our file. So under read mode, which is the default. So as f, and our input would be f dot read lines. So this gives us a comprehensive, no, yeah. So we have our input as a list of lines under the variable inp. Now all we need to do is for every element in inp, we need to separate the two numbers. So obviously we are going to have two lists. So for list one, which is going to be the list of the first historian's dataset, and list two, which is going to be a list of the second historian's dataset. Now, we need to separate the two lists first of all. So under every element, so for I in input, we need to, okay, first of all, our numbers are going to be nums is equal to I dot split over three spaces. So three spaces. So this is going to give us the two numbers side by side. And list one dot append I 0 integer of I 0, and similarly list 2 dot append integer I 1. So this is going to give us those two lists as this. So we're going to sort the two lists. So list 1 dot sort and list 2 dot sort. And finally, we're just going to calculate the difference between the two lists. So for every element, we're just going to subtract the two elements and just store the result in a variable. So our variable, which is going to be our answer. So initially it's 0. We're going to increment it as we iterate through the lists for the one last time. So for I in range length of list 1 or list 2, it doesn't matter. Our answer is going to be incremented by absolute value of list 1's ith element minus list 2's ith element. Finally, we're going to report our answer. So now that we have it up and running, we can, yeah, we have it right here. So we can just run this. So Python solution.py. Okay, so we are having a space here for some reason. We'll have to debug that. So list 2 is having some issues. Okay, so apparently there's a blank space after list 2, so dot strip should solve it because we have like new lines at the end of our strings. So still wrong. Okay, what does our list 2 look like right before it raises the error? Our list 2 is empty. It raises error in the first one itself. So right at this point, what does input look like? So right. So instead of I should be using nums because that is where I stored our values. So yeah, we have 11 here, which is supposedly our right answer. So if we just use our problem data instead of this, we should, in theory, get our answer. So 356,000 or 3 million? About 3.5 million. If I copy it and paste it right here, then that is the right answer. So that is my approach for this one. We'll see you in the next one. Thank you very much.